So we're talking about predators. There's going to be talk of food chains. Some of the vocab that you might need is phytoplankton and zooplankton, which I think is just the same in Italian. Krill, which is also the same. Various names of animals, but there are going to be lists, so you can really just name one or two and then say etc. Trophic cascade, cascata trofica. Carrion, and food chain, as I said. Thank you. And ecosystems. Okay. So a few years ago, the Japanese government was arguing for continuing to hunt whale. And the justification that it gave was whales eat fish. We need fish, so if we kill the whales, there'll be more fish for us, which on the surface of it sounds very logical. But as it turned out, it didn't work like that. They hunted whales, and the numbers of fish fell. The reason for this, it turns out, was that whales feed at depth, and then as they come up, after feeding, they come up to the surface, and they drag phytoplankton up with them. The phytoplankton then come to the surface where these are the plant plankton. On the surface they can photosynthesize, and also as the whales come up they leave what biologists call fecal plumes, feces basically, which also feed the phytoplankton. The phytoplankton stimulates the growth of zooplankton, which stimulates the growth of krill and fish. So by allowing the whales to survive and thrive, we're actually promoting the fish as well. Another side effect of this is the phytoplankton, which have been brought up to the surface by the whales. So they're photosynthesizing and absorbing carbon, and it turns out that they actually absorb huge amounts of carbon, and by killing the whales, we're not only damaging the numbers of fish, but we're also damaging the ocean's capacity for carbon absorption. What we see here is an example of what's called a trophic cascade, which is an ecological process which starts from the top and cascades down. Trophic cascades haven't been understood for very long. Only in the last few decades scientists have begun to understand them. Because previously, when biologists were carrying out conservation efforts, they used to start at the bottom. They said, okay, we're going to work on conservation in this area, we're going to start by regenerating plant life. And the plant life will stimulate insect growth, which will stimulate bird growth, and so on, up the food chain. But a lot of these efforts were not actually successful, and it turned out that what was missing was starting from the top. A lot of these efforts were much more successful once top-level predators had been introduced. So the effects of this then cascade down to the bottom of the ecosystem. Another example of a trophic cascade in action was Yellowstone National Park. In 1995, wolves were introduced into the park after they'd been absent for 70 years. In all of those years that the wolves had been absent, the deer population had exploded. Deer had taken over the park, they had overgrazed, and they'd done huge damage to the environment in the park. So in 1995, wolves were reintroduced, and the effects of this were completely unexpected. So the wolves ate the deer, yes, it's true, they reduced their numbers that way, but more importantly, the deer began to behave differently. They started avoiding certain areas of the national park. They started avoiding the valleys, the gorges, the closed-in areas where they were vulnerable to predators. Once the deer were not grazing in those areas anymore, the vegetation started regenerating. So trees started growing, grass started growing, because another thing was as the deer ran away from the predators, that pounding of their hooves aerated the soil and it created a better environment for grass to grow. So grass is now growing. Trees are growing, other vegetation is growing. And once the trees are growing, birds start moving in. Beavers also start moving in because beavers like eating the trees and they use the trees to build their dams. The dams that the beavers build create new habitats. They create eddies, they create rapids, they create pools. So in the rivers, new habitats are created for animals. So then you get otters and ducks and fish and amphibians and reptiles moving in. Another effect of the wolves is that they started eating the coyotes, and the coyote population had also exploded during the wolves' absence. So now that the coyotes were being brought back under control, there were more rabbits, there were more mice, there were more badgers, all of these prey of the coyotes. While the wolves were busy hunting the deer, they were leaving carcasses around after they were feeding. So animals like hawks and foxes and bears would come to feast on the leftovers. So here we have more animals, the population's being boosted. Because the bears were now being better fed, their population was boosted and they started boosting the effect of the wolves by also going and hunting the deer. And one particularly interesting effect was that the rivers started changing. Because the deer were avoiding certain areas and vegetation was regenerating there, the ground became more stable. The banks of rivers stopped collapsing, the banks of the rivers stabilized, and the rivers started becoming more fixed in their courses. And the same sort of effect happened as with the beavers and their dams, that new habitats were created in the rivers, now that their courses were a bit different. So all of this shows that the food chain is a very complex mechanism, and if you start interfering with one part of it, it can have wide-ranging and completely unexpected effects. A small intervention in one part of it can lead to huge differences in other parts of it. On the one hand, this might be a bit worrying because we can carry out a small intervention in the food chain and have effects completely out of all proportion. But on the other hand, it is quite reassuring because it means that if we intervene in the correct way, in this particular case by introducing predators at the top, then we can set right the damage that we've caused with minimal intervention. Thank you.